discussed this already. Okay, yung 5 groups of cations, and this groups is based on the reactivity of the cations. So we have 5 general groups. Short recap lang, the group 1, these are also known as the insoluble chloride group. So ang concept dito is these ions under group 1, they react with a dilute hydrochloric acid. Okay, so usually they precipitate out in the form of chloride salt. Halimbawa, the lead chloride. Okay, in our previous experiment, what you had there is the silver chloride. Tama? Then for mercury 1, you will form there mercury 1 chloride. Okay, that's why Hg2Cl2, because mercury 1 is Hg2 2 plus. So you simply crisscross no, the value 2 from the charge of mercury 1. That's why yung silver dito merong subscript of 2. Merciless, yan yung mnemonics natin, di ba? For list of ions under group 1. Okay, group 1. Next, we also have the group 2 cations. These are also known as acid insoluble sulfides. I mean to say they react with sulfides. Halimbawa ng sulfides would be hydrogen sulfide, or we can have the ammonium. Okay, ammonium sulfide. Ayan. Okay, under the acidic environment. Kaya mababa pH. So halimbawa ng reagent that could lower the pH for this certain reaction is halimbawa HCl, or concentrated hydrochloric acid. Okay, so that is the precipitating agent where these ions are very much reactive, forming the sulfide salt. So in our previous experiment, the one that was studied under group 2 is the copper 2 plus. Okay, that's why it will form, diba, the precipitate copric chloride. Diba, copric chloride, CuCl2. Okay, then for group 3, cations, these are also known as base insoluble sulfides. So base insoluble sulfides, the same main reagent, a sulfide group. You can have ammonium sulfide ulit, or dihydrogen sulfide, hydrogen sulfide. Okay, but this time in the presence of an alkali, no, an alkali to increase the pH. So halimbawa ng alkali is ammonium hydroxide, for instance. Okay, ammonium hydroxide. So last na ions that was studied is under group 3, it's the zinc, tama? It's the zinc ion, forming the sulfide salt or precipitate zinc chloride. Okay, zinc chloride. And then for group 4 cations, this is also known as base insoluble carbonates, or the acid insoluble sulfates. Okay, so we only have 3 ions under this group. Okay, we have barium, calcium, and strontium. So they precipitate out in the presence of a carbonate. Okay, so halimbawa, ammonium carbonate. Okay, that is the very common precipitating agent where these 3 ions react to. Okay, so ammonium carbonate is NH4 2CO3. Okay, carbonate in a basic environment. Alright. And lastly, the remaining soluble group, this includes the ions magnesium ion, sodium, potassium, and ammonium ion. Okay? Sige. So, for the proceeding reactions, chemical equations, this is what supposedly I should see on your output, no? These are the reactions that dapat nako makita in your output you had submitted last meeting. Sige, let's just have a, okay, recap lang pa rin to. Uh, yung diniscuss ko lang dito is the concept. Okay, here would be the specific reaction kung ano yung nangyari. Okay, on that particular procedure. Okay, so for the experiment that we had, diba, we have 5 cations that was studied. If this would be, if this is the test tube, we have added 5 ions, okay, in a form of test solutions. We have the silver nitrate. What else? It's a cupric sulfate, tama, and the rest nitrate, barium nitrate. Ayan. So these are the test solutions that was added. What else? The zinc nitrate. And then lastly is the, ano yung kulang? Silver, copper, zinc, sodium. Okay, it's a sodium nitrate. So lahat to mixed in one test tube. And the main goal is to separate each ions. So the first reaction is for silver nitrate added with hydrochloric acid. Okay, so among the ions again, among these ions in a test solution form, upon adding hydrochloric acid or dilute hydrochloric acid, the one that will only react to that is the silver nitrate, because the silver nitrate carries the silver ion, a group 1 cation, which is an acid insoluble group. Okay, forming now the silver chloride. So ito lang yung concept na diniscuss ko. Okay, sa taas. Silver ion is a group 1 cation, so it will precipitate out in the presence of hydrochloric acid. Crisscross mo lang yan. Crisscross yung concept in order for you to extract or predict the final product. Okay, syempre, silver chloride will be the precipitate kasi nandiyan si silver. Di ba yung purpose is i-extract, i-precipitate out yung silver. Okay, this would be the filtrate. Okay, yung nitric oxide, yan ay parte ng filtrate. Okay, parte ng filtrate. So the name is silver chloride, the color is white precipitate. Next, of course, upon adding the initial HCl, you'll have a preliminary interaction, no, with all the test solution. That's why on the first, ayan, on the first chemical equation for the rest of the ions, I have provided their reaction, okay, hypothetical reaction for hydrochloric acid. Okay, hydrochloric acid. Kasi HCl yung una mong nilagay. Okay? So yung mangyayari ngayon, on that filtrate, di ba, upon forming the precipitate, there is a water portion, not water, there is a liquid portion, okay, on top of the test tube. Apart from the precipitate, there is a liquid portion sa mismong test tube. That is the filtrate. Doon sa filtrate na yon, nandoon pa yung cupric, okay, cupric, barium ion, zinc ion, and sodium ion. But this time, they are dominantly in the form of their chloride solution. Okay, chloride solution. Okay, that is a liquid, a solution. Okay, then when we proceed on the procedure, okay, yung next step, diba, is we added a sulfide precipitating agent. Yung mismong inad ko sa binigay ko na video material, it's the ammonium sulfide. Okay, it's just the same if you add or saturate it with hydrogen sulfide. Okay, parehas lang naman yung magre-result na precipitate. Okay, so upon adding a sulfide, a hydrogen sulfide, or an ammonium sulfide, it will form the precipitate cupric sulfide. Okay, the cupric sulfide is color black. Okay, color black. Okay, this is what you have to take note about sulfide precipitates. Regarding sulfide precipitate, all are black. Take note. All sulfide precipitates are black in color, except. So meron lang tayong mga few exception. So please take note of the exception. We have the zinc sulfide. Zinc sulfide is color white. Okay? So, pag tinanong, it is the only white sulfide that is zinc sulfide. Okay, another, we have the cadmium sulfide. Ito naman, a yellow sulfide. Okay, yellow sulfide. Then we also have manganese sulfide. Manganese sulfide, this is salmon pink. Salmon pink. Okay. Then we also have antimony sulfide. Okay. Antimony sulfide. Ito naman kulay orange. Ayan. Kulay orange. So please take note of the exceptions. All sulfides are color black except the following. Okay, except zinc sulfide, cadmium sulfide, manganese sulfide. Okay, with regards to um, the mnemonics, okay, I can share to you my mnemonics, how I memorized the color of the sulfides, cadmium sulfide and manganese sulfide. Okay, so I simply consider cadmium sulfide as yellow cad. 'Di ba yung pizza, familiar kayo sa pizza na yellow cab? Yellow cab is color yellow, 'di ba? So babasahin ko siya as yellow cad. Cad for cadmium. Okay? So cadmium sulfide is yellow. And then for manganese sulfide, there is a saying na sabi, real man wears pink. 'Di ba? Real men, M-man for MN, for manganese. Okay, so real men wears pink. So manganese sulfide is color pink. That is just a mnemonics for you to easily recall, okay, what is the color of these sulfides. And then for zinc sulfide, this is quite a common sense kasi yung mga zinc compounds are all white in color. Most of the zinc compounds, zinc carbonate, zinc chloride, zinc sulfide, they are color white, white in color. Okay? Then ito, yung natira, i-memorize nyo lang to. Okay, orange. Antimony sulfide. Okay? Sige, next. Okay. After precipitating out the cupric sulfide, so mayroon na lang tayong tatlong ions na natira on the test tube, okay, on the test tube itself. So padayon ta. The next procedure is adding sulfide pa rin, saturating the solution with a sulfide, hydrogen sulfide, or yung binigay ko nga na demonstration for the experiment for, I simply added ammonium sulfide, the solution form ng sulfide. Okay, so basic naman to at the basic environment. Okay, so if that is the case, if that is the precipitating agent, sulfide in the presence of basic environment, then the ion that will precipitate out would be a group 3 cation, and that would be zinc. So zinc, reacting that with a sulfide group, that will precipitate the compound zinc sulfide. Kaya nakalagay dyan, zinc sulfide yung pangalan, then the color of the precipitate is already given, di ba? Sa video material, it's color white. Okay? So may natira na lang na dalawang ion sa mismong filtrate, sa mismong liquid portion ng test tube. Okay, so may barium tsaka sodium. So proceed on the next procedure sa mismong lab guide na binigay sa inyo. What is then added? It is added with ammonium carbonate. If you can still remember, there is an addition of ammonium carbonate. And recall, ammonium carbonate is one of a precipitating agent sa isang particular group of cation, and that is group 4. Diba sabi, group 4 cations are base in soluble carbonate. So whenever these ions are being reacted with a carbonate at the basic environment, it will form insoluble compound, a precipitate. Okay, so in this case, you have a barium ion, which is a group 4 cation, being reacted with ammonium carbonate. It will form a carbonate salt, the barium carbonate, and its color white. Okay, so na-extract na lahat. Okay, na-separate na lahat yung mga ions. Yung mismong natira, yung hindi nag-precipitate out, yun yung sodium. Okay, sodium ion, since it is a group 5 cation, it will never react with any of the reagents being used in the chemical reaction. It will not react with HCl. Okay, it will not react with hydrogen sulfide at an acidic environment. It will not react with a sulfide group at a basic environment, and even sa ammonium carbonate, it will not react. Okay, so that's it for experiment number 4. Question. Do you have a question? Okay, none. Okay. Sige, since there's no question na, let's proceed directly no, to the next experiment. Okay, it has something to do with the same concept, qualitative analysis pa rin. So somehow you already have an idea na how to um, analyze no, reactions of ions. Okay, specifically cations. Yes. What is it, Mr. Jason? What about flame test? Okay. Okay, allow me to share my screen. Okay. Excuse me. Okay, I hope the screen is already visible. Is it already visible? Can you hear the audio? Please type in your response. Maklaro lato ato ako ang gi-share ganina ang audio lang. Okay lang. Okay, dili na need ang audio. For a while ha. Yes, dili na kailangan ng audio. I will discuss. Okay? The video material I extracted from the YouTube. Okay? Syempre, if I will be using the learning platform, YouTube, if I will extract a video from YouTube, I will not allow you to just access that without understanding what you are accessing. Okay? Sige lang, ako i-discuss siya. Okay, ayan. So I hope it is already visible, including my audio. Okay, so for this, excuse me, for this morning naman, we will have a new experiment. Okay, experiment 5, this is all about qualitative analysis of group 1, cations. Okay, pag group 1 cations, tatlong ions lang yun, di ba? Tatlong ions. And you know already what is the mnemonics. Okay, group 1 cations. So those ions that react with dilute hydrochloric acid. Okay, now for this experiment, this is also known as reactions of the silver group or the ions separated as chlorides. Okay, so again, pag sinabing group 1 cations, you can zoom in ha. If you're using a cell phone, you can zoom in whatever I am presenting to you. If you're using a phone, okay, or an iPad, you can zoom in, okay, what I am sharing. Now, group 1 cations, please take note, these are also known as silver group. Okay? These are also known as silver group or yung na-mention last meeting, di ba? They are also known as insoluble chloride groups. Insoluble chloride groups, group 1 cations yan. Ibig sabihin, they precipitate out or they are being separated as chlorides in general. Okay? And yun na nga, in some other references, they are also known as the silver group. Okay? Bakit silver group ang tawag sa group 1 cations? It is because yung flag bearer or yung leader, kumbaga, yung first on the list sa cations under group 1 cations, it's 'di ba silver? Particularly, is it silver 1 or yeah, it's silver 1. It's not mercury. Okay? Mercury 1 yung merong another variable charge. Okay? So I repeat, flag bearer, leader, first on the list under group 1 cation, it's the silver 1. Okay? So recalling all the members under group 1 cations, merciless, mercury 1, silver 1, and lead. Ito yon. Okay? Mercury 1, silver, and lead. Merciless, yung mnemonics under group 1 cation. So, the main goal under this experiment is, of course, for you students to differentiate, okay, or identify the different precipitating agents, okay, ng mga group 1 cations. Although, yung una, alam nyo na yung unang precipitating agent nila kasi 'di ba they react with chloride, particularly dilute hydrochloric acid. Okay? And dito malalaman natin yung iba pang okay, precipitating reagents no that are used for these ions. Okay? Another goal objective is for you to know the different properties, okay, based on the reactions, the different properties based on their reactions, and also to identify the confirmatory tests for the selected cations, no? Okay, under group 1. And I repeat, yung concept lang po dito is almost the same to the previous experiment. Okay, yung experiment 4, the same lang. 'Di ba? Kung naaalala nyo, sa experiment 4, you have a single test tube. Isa lang po yung test tube. Okay? Wherein in that single uh, test tube, it contains the solution of the 5 ions. Okay? Yung 5. Okay? Nasa isang test tube. And then, we separate each ions into groups using their main precipitating agent. Now, for this experiment naman, yung qualitative analysis of cations, ibig sabihin lang po, this time, in one test tube, ito sila, okay, are contained, okay, in that one test tube. You have a silver test solution, a lead test solution, a mercury 1 test solution. They are mixed in one test tube. Okay, and dapat ang goal natin is to separate. Separate natin sila kasi minix natin sila into one test tube. Ganun pa rin po ang concept. We have to separate this, okay, each ion, okay, singly, okay, individually. And posible yan via performing qualitative analysis. Diba yan naman yung idea sa qualitative analysis. We are separating here, we are identifying cations here. Okay, or ions, the anions also. Okay. So here I will be presenting to you the procedure. Okay. This was again extracted from the YouTube. You can search this also in YouTube. Just take note of the ayan, the labeled okay, name okay, from the resource material. Okay? Sige. So, let's have first the first procedure. Ang sabi sa first procedure, okay, kindly read, Miss Jadman. Is Miss Jadman present? Andito pa si Jadman or baka Block C or Block B siya, no? What about Miss June Rose Corvera? Is she here? Okay, kindly
Yes,
read.
ma'am.
Okay, read.
The first question, ma'am, no?
The first procedure.
In a test tube, place 5 drops each of the test solutions for Hg plus, Pb2 plus, and HG2 plus. On a separate test tube, place 15 drops of distilled water as a negative control.
Okay. So what is she reading will be demonstrated in this video. Ayan. So as you can see, the test solutions used for silver, lead, and mercury 1 are all in nitrate. Ayan. Are all in nitrate test solutions. Almost the same with the previous experiment. Halos lahat nasa nitrate test solutions, tama? So no problem with that. Silver, lead, mercury 1 in their nitrate test solutions. And again, they are being mixed equally in one test tube. Ayan. And on a separate test tube, merong negative control. Siyempre, yung negative control, it's just the water. Yung positive control natin, yun yung nandoon, yung tatlong ion, yung tatlong group 1 cation. Nakuha? That is the first procedure. First step. So, yan yung ginawa niya. Oops. So, meron na. On this test tube, this is the positive control. Take note. Yung positive control, again, it has the 3 ions. The negative control is just a water. Para saan yung negative control? That is just a, pag sinabing negative control, whatever you add on that solution, it will not give you a positive reaction. Okay? Just a negative reaction, no reaction, inert. Walang reaction na mangyayari, whatever you add on that negative control. Okay? Sige, next step, kindly read. Sino yun? Jason. Is Jason here? Sige, basa. Wala ba siya? What about, sino pa yung nag-comment?
Okay, ma'am. Ano ko, ma'am?
Okay. Asa naman to ato ang... Okay. Sige, pakibasa.
Place 2 to 3 drops of 6-MHCl to both test tubes. Stir. Note the color of the precipitate of silver. Nakalimutan ko.
Lead.
And ano?
Mercury. Okay, thank you. Okay, kindly turn off your audio. Okay, thank you.
Mabili na po, ma'am.
Paki-turn off your audio. Audio, paki-turn off.
Ma'am, bili na po, ma'am.
Off, palihog imong audio, off. Asa naman ka?
Si Jelly makalulot, ma'am.
Ay, kinsa man ang nag-on?
Si Jelly.
Si Jelly. Asa naman mo? Okay. Please be mindful ha when you are attending a class A. Turn off gud inyong mic unless you're asked to. Okay. Sige. So ang step 1.2, place HCl. Okay, yung tanong ko, these are group 1 cation, silver, lead, and mercury. Do you think upon adding HCl, a precipitate, an insoluble precipitate will form? Yes or no? What is your answer? Do you think there will be a precipitate? Yes, of course. Kasi nga, di ba, they are group 1 cations. They are ions that are insoluble in chloride. No, in chloride reagent. Okay, sige, let's proceed on the next step. O, tingnan. After adding the ion sa positive control, sa negative control, there is water. Next step, we added, no? There is an addition of HCl to both positive and negative control. And try to observe. All the 3 ions react with hydrochloride. And that is expected because they are group 1 cations. Okay? Now, ngayon, you note the color of the precipitate. So, you know already what is that color. So, you can answer that part. Okay, sa worksheet. Okay? Again, this is just a negative control water. Hindi po tayo mag-o-observe sa negative control, only on the positive control test tube. So, you can see Ito yung uh, you have to take note na whenever there is turbidity, when there is cloudy formation in a solution, that is an indicator that a precipitate is formed. I repeat, when there is a cloudy, okay, or turbidity that is formed in the test tube, that is an indicator that a precipitate is formed. Okay? And remember, just like our experiment last meeting, when we separate the filtrate from the precipitate, when we separate the filtrate from the precipitate, we use the process centrifuging. Okay? So we use the equipment centrifuge. Naalala yung centrifuge? Okay. Ayan. So isa-centrifuge natin siya para ma-separate. Okay? Yung precipitate from the filtrate. Okay? So recalling the rationale uh, ng centrifuge, 'di ba, yung concept lang doon is to separate the solid from the liquid portion. And kung titingnan mo, the test tubes, the negative and the positive control test tube, it has to be placed opposite each other. Okay, the reason bakit opposite to each other siya placed inside the centrifuge, the concept there is to keep the balance, to keep the balance. Okay? Kasi 'di ba, yung test tubes inside the centrifuge, it will spin. Okay, it will spin at extremely high velocities. So imagine nyo, it is spinning, so dapat ma-maintain yung balance. Kasi any irregularities in the mass, okay, between the test tubes inside, that could result in stability already of the system, or that could cause a damage of the equipment itself. Okay, so dapat balance siya. Okay, balance siya whenever a material is spinning, di ba? Ayan. So that is just the concept. Bakit opposite each other siya nilagay inside the vessels of the centrifuge. Okay, bakit ulit yung centrifuge? To separate the filtrate from the precipitate. Kasi may nabuong precipitate. We cannot separate that turbid solution if hindi natin siya i-undergo ng centrifuging. Okay? Ayan, centrifuge. Ito yun ang like. Centrifuge sa two test tubes. So yan na yun. Centrifuge. O, tingnan nyo, di ba? Umiikot sa loob. Okay? So that's the reason bakit opposite to each other ilagay yung test tube. O, ayan na. So as you can see, from the turbid solution kanina ng positive control test tube, you can see here, clear na ngayon yung filtrate, yung liquid portion sa taas. Then, you can now easily separate the precipitate from the liquid portion. Okay? O, yung tanong ko, sa precipitate na yan, ilan yung ions na na-precipitate? Okay? Sa insoluble material na nasa bottom part ng test tube, ilan yung ions na na-precipitate? Very good. It's 3. Okay? So, that particular precipitate are the chloride precipitate. So, you know already what is the chloride form of silver, lead, and mercury. So, you can simply write silver chloride, lead chloride, at saka, ano yung isa? Mercury 1 chloride. Okay? So, ito yung gagawin nyo for this worksheet. Okay? Sa baba, di ba? Sabi dito, complete the table. Okay? Di ba yung unang step is you have these 3 solutions. You added, TS means the test solution. You added not silver, hydrochloric acid. You are simply asked here the color of the precipitate. So sulat nyo, ano yung kulay ng precipitate? So you know already, that's already your part, no? Job to fill in. What is the color? Yung nakita nyo kanina. And then, what is the name of the precipitate form? So silver chloride. Tama? Kasi chloride yung inad. Dito, lead chloride. And dito naman, mercury 1 chloride. Okay? So provide the name and the formula of the precipitate only. Follow the instruction of the precipitate only. Okay, so yan yung gagawin nyo for that portion. So asa na tayo? Diba dito na tayo? Sige, kindly read Crazel. Is Crazel here?
Yes, ma'am.
Okay.
Test for completeness of precipitation by adding 2 drops of 6 moles hydrochloric acid to the supernatant, then mix the solution using a stirring rod. Once again, centrifuge the test tube for positive control. Separate the centrifugate by decantation.
Okay, thank you. So, yung next na proceeding step, we simply wanted to test the completeness of precipitation. Baka kasi sa mismong liquid portion dyan, baka may natirang traces pa ng silver ion, may natirang traces pa ng mercury, lead ion. So, we simply add more HCl. Okay? That is again to test the completeness of precipitate. Okay, so kapag nag-turbid siya ulit, meaning may na-detect pa rin si HCl na ions of group 1, no? Group 1 cations. Okay. Ayan. So adding more HCl, again, the purpose is to test the completeness. O, kapag gigi-steer niya, okay? For sure, iyahan na lang, for assurance na lang ang purposes, iyahang gi-steer. Okay, upon adding the HCl. And then, i-centrifuge niya. So, ito na. Okay? So, ito na yung completely separated na precipitate. Maklaro man siya, no? Yung white portion, yan na yung silver chloride, mercury chloride, and the lead chloride. Sige. Proceed tayo on the next step. Pakibasa. Sino pa ba yung present? City. Andito ba si City?
Yes, ma'am. Asa nga ano, ma'am?
Itong highlighted one.
Okay. To the precipitate, add 1 ml of water and mix using stirring rod, then centrifuge and separate the supernatant by decantation.
Okay. Sige, proceed tayo. From the precipitate, yung kulay white na precipitate, add water. So, i-pour muna niya yung supernatant, that is also the filtrate. The supernatant, that is also known as the filtrate. Yung upper liquid portion. Yung upper liquid portion, supernatant or filtrate. Okay. So, yung natira dyan sa bottom ng test tube, it is being added. Ito yung inadan. Okay, inadan ng water. Kasi sabi dito, add water sa precipitate, hindi naman sa filtrate. Okay? Then mix. Mix ulit with stirring rod. Okay? Ayan. Sige. So, next step. So, this is just the precipitate. Ito yung precipitate kanina. Okay, ayan. Precipitate na nilagyan ng water. Okay? Nilagyan na siya ng water para may solution ulit tayo. May solution ulit tayo for testing. Okay, ito, negative control lang po to. Meaning walang reaction na mangyayari dyan sa negative control. Okay, let's proceed. For the second general procedure is, ang goal, to separate the lead. I repeat, to separate the lead ion. Okay? Sige. Let's kindly read the 2.1 procedure. Joanne. Is Joanne here? Andito ba si Joanne?
Yes,
Okay.
ma'am.
Okay.
2.1. Test the solubility of the precipitate by adding 1 to 2 ml water bath. Write your observation in row 2.1 in table 8.2, soluble or insoluble.
All right. Sige. Okay, so testing of solubility this time of the precipitate. Sige. Ito, centrifuge lang muna. Okay, proceed ta ha. Sa testing of solubility na tayo. Ay, nabalik siya. Okay, ayan na. Na ano siya, na backward siya, no? Sige. Sige, ayan, ayan. Balik. Naman to. Okay. Okay. Excuse me. Ayun. So this is for the separation of lead ion. Paano? It is being added with, ayan, 1 to 2 ml. Okay? Boiling water. Okay? And then heating that under a water bath. That is the process to separate the lead ion. Ayan. Addition of 1 to 2 ml water and placing it to a water bath. Excuse me. Ayan. Okay. So please take note of the solubility only. Sinabi naman dito, 'di ba? To separate the lead, add boiling water. Yung tanong dito lang po, yung tanong lang dito is it soluble or insoluble? Is the lead chloride formed from the initial procedure soluble with the boiling water or not? Yeah, sabi dito is at high temperature, okay, lead chloride is dissolved. Okay, so you know already if it is soluble or not. Okay, so asa ilagay ang sagot dito sa baba. 'Di ba nilagay mo dito na precipitate is lead chloride, 'di ba dito? Upon reacting HCl, the precipitate is lead chloride. For the solubility with boiling water, syempre dito ka lang maglagay ng uh, the one that is being asked to you. Okay? For the rest, negative man yung result, so you simply write the opposite. Okay, the opposite. Okay, so you know already kapag lead chloride will dissolve, syempre, is it soluble or insoluble? So you know already, ha? Sige, next. So okay na diha. Dito naman. Okay, kindly read. Sino pa ba yung present? What about Fatima Jadman? Are you here, Fatima Jadman?
Yes, ma'am. Good morning.
Okay. Sige. Pakiread. Okay.
Kanang kuan, ma'am. Kanang stir.
Highlighted.
Okay. Stir the solution from time to time while heating. Centrifuge the solution. Then separate the filtrate or supernatant to another test tube. Then place the test tube with the remaining precipitate on a test tube rack.
Okay. Sige, tama. Okay. Atong i-recap ha basing wala na catch up sa uban. 'Di ba from the initial step may na-produce tayong chloride precipitate. Yung mismong kulay white. Yun yung tinest natin dito. Okay? Yun yung tinest natin dito, yung mismong mga precipitate. It is being added, di ba, with water and then gicentrifuge, decant. From that precipitate, yung solid, yung insoluble portion, it is being added with boiling water. Yung purpose dito is to separate the lead in a form of lead chloride. Okay? So yung precipitating way separating process natin dito is via adding boiling water. So sa tatlong chloride, na-precipitate out, na-separate out. Na-separate out na natin, okay, from that solution si lead. Okay, na-separate na natin. So yung natira, ilan na lang yung natira? From the precipitate. Asan man gani mo? Okay, very good. Dalawa. So I hope nakuha ha. Sige. Okay. Sige, next. So ito lang yon. Ayan na. The remaining precipitate will be, of course, the silver chloride and the mercury chloride. So, yan lang po yung binasa ni Miss Jadman, steering. Para lahat ng lead ion, okay? Lahat ng traces ng lead ion ma-dissolve natin. O, kapag na-dissolve sa mismong solution yung lead chloride, nasaan na ngayon si lead chloride? Nasa filtrate or nasa insoluble portion pa rin? Asagay mo dapit. Nawala mo. Ayun. Nasa filtrate portion na ba siya kapag na-dissolve si silver chloride? Nasa upper or nasa lower portion siya? Kapag sinabing upper, nasa supernatant na siya. Pag sinabing lower, nasa precipitate portion or the insoluble portion. Kapag sinabing na-dissolve, very good, sa upper portion. Okay, nasa upper portion. Kasi nga, na-dissolve siya, dapat ma-liquefy siya, sasama siya doon sa liquid. Okay? Ayan. Ako doon i-exit be. Ayan. Okay, next. Yung ginagawa lang niya dyan is gibalance lang niya the volumes. Kasi again, kapag centrifuging, we have to keep in mind the concept of balance. Okay? Ayan, centrifuge pero totally ma-separate yung bottom part from the upper portion. Kasi nga, separation, we are separating something here. So very important yung centrifuge dyan. O, ayan na. The lead ions, take note. The lead ions are now in the filtrate. It is now on the supernatant kasi nga na-dissolve siya. Na-dissolve siya with boiling water. Meaning to say, yung silver at saka yung mercury, hindi sila soluble sa boiling water. So, yan lang po yung point. Ayan. So, the supernatant is being transferred sa test tube. O, yung tanong ko, ano ulit yung ion na nasa supernatant among the three? Ano ulit yung ion na nasa supernatant? Yung tinransfer ng mismong nagdemo. Medyo lag yung chat box ko, no? Sige, I will wait. So, the three ions. Very good. It's the lead ion. Okay, it's the lead ion yung nasa supernatant. Okay, from that supernatant, we will now identify. Kapag sinabing identify, we will like to confirm. Okay? We will be confirming the presence of the lead ion on that supernatant. So, ito yung process para ma-confirm natin kung lead ba talaga yung na-dissolve using boiling water. Okay? So, ito yung confirmatory kung si lead ba talaga yung na-separate, yung unang na-separate, na-separate via dissolution process. And then again yung solid na natira, it contains the silver chloride pa at saka mercury 1 chloride. Excuse me. Dito na identification of lead. The confirmatory test for lead ion. Ayan. So to confirm, we simply add acetic acid. 6M means 6 molar. The molarity, that is just a concentration. Okay? So added with acetic acid to the filtrate and a few drops of potassium chromate. So ibig sabihin, you have the main precipitating agent or confirmatory agent, potassium chromate, at an acidic environment. Okay? So ang main precipitating agent ulit to confirm lead ion sa supernatant sa filtrate, it's the potassium chromate. You know already the formula of potassium chromate in an acidic environment. Yan yung kailangan to confirm Okay. So ayan na, acetic acid, okay? And then potassium chromate. Then if ever that will form a yellow precipitate that is a positive, no, positive result na lead ion is really separated. Okay, separated already. Yung gitas niya nga filtrate, merong lead ion. That is the visible result. Okay, positive visible result. So, ayan. So, as you can see, there is a turbid yellow indicator nga merong precipitate na na-form. Ibig sabihin, na-detect ni potassium chromate yung lead ion. Okay, so you know already what is the reaction. Lead, sulat nyo, lead chloride plus potassium chromate. Then you can now identify what is the precipitate. Kasi andito sa next na table, okay, di ba, from lead chloride, confirmatory test with potassium chromate. Yung ion lang, di ba, nga lead, ang for confirmatory test with potassium chromate. So dito nyo ilagay yung sagot nyo. Okay? So sabi, write the color. So you know already what is the color. Write the name and the formula of the precipitate. You simply react. Lead chloride, di ba lead chloride yung precipitate na na-dissolve natin. From precipitate, na-dissolve natin siya with boiling water. So lead chloride plus potassium chromate, what is? What do you think is the precipitate? Anyone? Lead chloride plus potassium chromate, what is the precipitate? It's the crisscross lang po. Siyempre, dapat nandoon si lead, nandoon yung anion ng precipitating agent. And it is the lead what? Very good. It's a lead chromate. So, yan lang. Okay, very good. It's a lead chromate. You will know easily by just looking at the reaction. Dapat yung mismong precipitate, nandoon yung gusto mong i-precipitate, nandoon yung ion na gusto mong i-precipitate, followed by the anion. Kasi cation na to. Dapat partner niya is the anion, the chromate. So lead chromate is the name of the precipitate here. So dito ka lang maglagay ng sagot ha, kasi it's only the lead, okay, that is being confirmed using the potassium chromate. Okay, that's 3.1. Careful mo sa pag-fill in sa answer. 3.1, sorry. Okay, so that is only for the identification of lead. Okay, let's proceed. Okay, so no problem with that. Next. Okay, from the original nga test tube, okay, mula sa unang test tube na ginamit natin, di ba meron pang precipitate na nandoon? Si silver chloride tsaka si mercury chloride. So this time, separation and identification of the mercury ion. Okay, mercury ion naman. I repeat, proceed ta atong nabilin nga precipitate kasi okay na si lead. Proceed tayo sa natira. Lead, not lead, silver ion at saka mercury ion. Silver ion at saka mercury ion. Ayan, separation and identification of mercury. So yung nandito na solution, mercury chloride ha, what is being added? Ammonium hydroxide to the remaining precipitate. Okay, tanong ko, yung sinasabi nating remaining precipitate kanina, ilan ulit yung ions pa na natira doon? Ilan ulit yung ions pa na natira? I am just checking if you can still catch up. Okay, very good. Dalawa pa. Si silver ulit in a form of silver chloride at saka si mercury ulit in a form of mercury 1 chloride. What is now being added to that precipitate? Ammonium hydroxide. Para saan yan? To separate and identify mercury. Okay? Sige. Ammonium hydroxide. Oh, you observe what happened. Again, para saan yan? Para ma-separate natin si mercury. Oh. Oh, you can observe a reaction. May reaction, di ba? And what is the color of the, ayan, insoluble portion? Diba? That is kulay black. You know already. Excuse me. So, na-separate out natin si mercury. Okay, si mercury ion. Okay, forming black particles. Okay, yung black particles actually, that is the mercury metal. When you say mercury metal, that is only Hg. Hg. Oh, ayan. It's the liquid mercury. Okay, the mercury metal, that is the black precipitate being formed. And yan lang diba yung tinanong. Okay? What is the color? Color only of the precipitate. Its kulay. Oh, it is being mentioned already. Black. Oh, pagdating dito sa table, 4.1, so asa ra ka mag-fill up sa tatlong column, diri ra ka mag-fill up for mercury. Nakuha? Kasi it's the mercury chloride that is being reacted with ammonium hydroxide that reacts with ammonium hydroxide producing a precipitate. Okay, so what is again the color? You simply write black. And what is the name of that? It's the mercury metal or the liquid mercury. The formula is Hg only. Walang charge, zero yung charge. Hg. That is the liquid mercury metal. Okay? O, na-separate na natin, no? Na-separate na natin yung mercury. Tama? O, yung tanong ko, 'di ba may isa nang natira na ion kasi tatlo lang lahat. Na-separate na natin si lead una. Then now, na-separate natin si mercury. O, yung tanong ko, do we still need to separate the remaining? Do we still need to perform a separation method for the remaining ion? No. Kasi isa lang naman, meaning na-separate na natin lahat. 'Di ba? Na-separate na natin lahat. Very good, everybody. Okay? So, kaya nakalagay dito is simply identify. Meaning, i-confirm lang natin kung yung natira ba talaga is silver. Kasi separate na natin yung dalawa. So, i-confirm lang natin kung yung natira is silver. Okay, so meaning, doon sa supernatant na yan, nandoon yung natirang silver. Okay, nandoon yung natirang silver ion. O, ito na, identification only. Okay, identification only. Confirm lang natin kung silver ba talaga yung natira via adding nitric acid. Nitric acid. And mind you, class, nga when you add, sulat nyo na lang ha, when you add nitric acid to a silver ion, it will bring back the chloride ion, chloride salt of silver. Okay, so meaning mapo-form again si silver chloride. And you know that silver chloride is a precipitate. It is a white precipitate, tama? So upon adding nitric acid, tingnan. Okay, observe, upon adding nitric acid to the supernatant with silver ion, you can see there is white. There are white, no? White turbidity nga being observed. That is the silver chloride. Recall, silver chloride is a white precipitate. Okay, so confirm na silver talaga yung andyan using nitric acid. Nakuha? So that's the identification method. O, ayan na. Ito yung from left. So dito, from left, positive result ito for lead 2, forming the lead chromate. Then itong black portion, it's the mercury metal, di ba, na na-form. So na-separate. Separate ang lead, na-separate yung mercury, then forming now the silver ion. So ito yung natirang silver. Ito, negative control lang to, di ba? As you can see, kahit anong ina dito, walang reaction. Kasi nga negative control lang yan. Hindi po yan kasali dito sa worksheet. Nakuha? Note the color. Oh, alam nyo na ano yung kulay. Okay, sa last portion. So dito, sa last table, from the filtrate, added with nitric acid. So asa lang mag-provide og answer dito lang sa may silver column. Upon adding nitric acid, di ba, the precipitate is again silver chloride. What is the color? Oh, you know already what is the color. Okay, so ayan. Di ba, this is the silver chloride. So you know already that color, ha? Ito naman is for the equation only. Kung ano yung mga reaction na nangyari dito, particularly, simply provide what is being asked ha, yung 1.2 nga reaction, ilagay mo lang kung ano yung complete equation. So you know already how to write ha, chemical equation. It has a reactant and it has a product side. Yun lang po. 1.2, so anong reaction ito? 1.2, ito yon. Kapag 1.2, ito lahat na reaction. Silver nitrate plus HCl. Kasi ito na lahat nag-react, di ba, with HCl. Ito lahat nag-react with HCl. Yan yung ipro-provide nyo for 1.2. Next, 3.1 procedure. Ano yung equation na ilalagay nyo? 3.1. So yung confirmatory test only for lead. So ibig sabihin, lead chloride, di ba lead chloride na dito? Lead chloride from that precipitate, it is being confirmed using potassium chromate. Yan lang po yung reaction na ilalagay nyo for 3.1. And lastly, 4.1. This one. Okay? So 4.1, that is for mercury. Tama? That is for mercury chloride being reacted with ammonium hydroxide. So you provide the chemical equation. Ako ha? Then just a short conclusion, okay, about this activity. So that is all for worksheet 5. Okay, so halos binigay na lahat ng sagot. Okay, sige. So you still have 2 hours again. 2 hours to accomplish your activity for this morning. Okay, do you have questions? Tanong. Okay, none.